Java WebSockets API is a new API introduced in Java EE7. So what exactly is this API used for? It's an API for developing real-time web application. So what exactly are these real-time web applications? Let's see some examples. So here shown some sample real-time web applications. So a chat application is a very common example of a real-time application. Then over here I shown a cricketing scoreboard which is updated as the match progresses. Over here is a stock market site which shows the latest indices, and over here is a scroller which we can see in many news websites which shows the latest news. So the common theme among all these applications is the information is fairly shown in real time. So real time means the timely nature between the occurrence of an event and the entity who is listening to the event is made aware of it. So for creating this real time web application, the following techniques were adopted. So over here I shown some techniques: polling, long polling, HTTP streaming, and WebSockets. The starting three methods are based on HTTP protocol, and later on we'll see that the protocol itself is a problem for real-time web applications. Now HTTP protocol provides half duplex communication. What do you mean by that? So over here I've shown a sample request response. Now the way HTTP works is the client sends a request and the server responds to the request. At the time on the wire, only the request is there or the response is there. So it's half duplex. Now, if you imagine a real-time web application like a chat application between the client and the server, then the server cannot respond until it receives a request from the client. So this is not the way how chat applications work. So this half duplex nature of the server responding only when the request comes from the client is problematic for real-time web applications. So the following techniques were piggybacked on the HTTP protocol for developing real-time web application. So let's consider the first technique, which is polling. In polling, the client sends requests to the server at regular intervals. So if information is available on the server side, it sends that information, and if information is not available, it responds in negative. So from this diagram itself, you can see the shortcomings of this method. So lot of empty messages are being exchanged between the client and server. Imagine if there are clients in the order of thousands, then humongous amount of empty messages will be exchanged and the server will get loaded. So as an improvement over polling, the next technique of long polling was evolved. So over here I've shown the long polling technique. In long polling, the server doesn't close the HTTP connection as it was done in polling method. So over here, the connection was closed when the server responded to the request. Whereas over here, the connection is open for a set duration of time. In that duration, the connection is not closed. When the duration limit is reached, the connection is closed. So over here, for the first duration, the client issues a request and the server has no information available in this time duration. So at the end of this duration, the server closes the request. Same goes for this case over here. In this third case, the client issues a request and server does have some information for the client. So over here, the server responds to the request and the connection is closed over here itself. Then the client issues another request, and for that set duration, again server makes the connection open. So basically in long polling, the connection is closed either after a set time duration or it's closed when new information is available. So even though this technique saves us from the tremendous amount of empty messages sent in polling, this technique does have serious disadvantages. The main disadvantage is bidirectional communication. The trouble is, when the client issues a request, the server either waits for a specific time duration before closing the connection or sends some new information and then closes the connection. During this period, the client cannot send messages, client cannot communicate with the server over the same connection. So the client has to open a new connection to the server for sending any messages. Another problem with long polling is there is a short duration in which the client and the server are out of sync. So over here, in this short duration after which the server has responded and before the client issues a new request, in this duration the information is out of sync between the client and the server. So if such a small interval matters to you, then long polling is not a technique for you. So as an improvement over polling, the streaming technique was introduced. So in HTTP streaming, The client, or rather the server, doesn't close the connection when it receives a request. It keeps the connection open either for a specific time duration, or it doesn't close the connection at all. So in this duration, whenever new information is available, the server responds or sends a response to the client. It doesn't close the connection after it sends the response. So over here, some sample responses are sent from the server to the client. However, the same problem persists like long polling, that when the client has sent the request and the server has kept the connection open, the client cannot use the same connection for sending further request. It has to open a new HTTP request for sending further information to the server. So the inherent problem with all these techniques is the protocol itself. HTTP protocol, being a half duplex communication protocol, creates problem for real-time applications. So, considering this need for real-time web application, a new protocol, that is WebSocket protocol, was developed. It doesn't piggyback on the HTTP protocol, it's an independent protocol. Now, unlike the HTTP protocol, the WebSocket protocol provides full duplex communication. Let's see this diagrammatically. In the WebSocket protocol, the client sends a HTTP client request to the server for making a connection to the server. The server responds to that request. After this initial handshake, the client and the server are said to be connected. Note that even though the initial handshake takes place over HTTP, this is not the HTTP protocol. It's the independent WebSocket protocol. So after this, data frames are exchanged between the client and server. There is no time duration, and data transfer takes place over the single WebSocket connection. So let's understand this initial handshake in much more detail. So over here, the client issues the request and the server responds to that request. Now, the connection type or the connection header in the request is upgrade. So the client wants to say that it wants to upgrade the connection from HTTP to WebSocket protocol. So these two headers are important for the upgrade. So connection upgrade says that it wants to upgrade from the HTTP protocol, and upgrade header says that it wants to upgrade to the WebSocket protocol. Also, the client provides a challenge to the server in the form of this header field over here, that is sec WebSocket key. The server takes this key, performs some calculation, and provides the answer in this field sec WebSocket accept. So the client will perform the same calculations, and if this matches with what the server has sent, then this connection is successfully established. Also, the server responds with 101 status code, which is the status code for switching protocol. That is, the server is okay with switching to the WebSocket protocol, and that's what it conveys to the client. And if you're curious about the calculation of this field, here is how it is done. First, the server takes the WebSocket key header field from the client request, which is mentioned over here, and then it appends this magic string over here, and then it performs SHA1 hashing, then it's base 64 encoded, and that's what the value is there in this WebSocket accept field, which is mentioned over here. Anyways, the client doesn't provide this challenge to test the abilities of the server, but it prevents some unexpected or unsuspecting server from upgrading to the WebSocket protocol. So as part of HTML5 connectivity for real-time web application, the WebSocket protocol was introduced, and which we have seen till now. And also JavaScript WebSocket API was created for creating one endpoint or the browser endpoint of the WebSocket connection. So Java EE responded to this new WebSocket protocol by creating the Java WebSocket API. Using this API, we can create the other endpoint of the WebSocket connection. So in addition to the support in the Java EE server environment, it also provides the client API for making desktop applications connect with the Java EE WebSocket server. So in later chapters, we are going to use both these techniques of using the JavaScript API as well as the WebSocket client API for connecting to the Java EE server.